Today we're going to cover Chapter 5, Section 3, and today we're going to learn how to evaluate trigonometric functions. So first thing we're going to do is review some geometry content. And in my class, when I teach this to my geometry class, I teach them this acronym to help them to remember what sides of the triangle to put into each trig function. So my acronym is SO, CA, TOA. So for the sine, that's going to be the SO. So this is the full word, S-I-N-E, but it's really on your calculator, it's just S-I-N. And whenever we do the SOHCAHTOA, it's always going to be based off an acute angle of the triangle, not the right triangle or the right angle. So if I draw a triangle up here, and let's say I'd say this is B, A, C, and the right angle is here, I'm going to write these 6 trig functions all referencing my angle A. So what I need to do here is I need to go ahead and label the hypotenuse first. That's the side across from the right angle. And then the side in relation to angle A, that is opposite, will be over here. And a lot of times what we're going to see when we get to 5-4, we're going to label the side across from the capital A as a lowercase a, and then the side across from angle B will be lowercase b, and this one, in relation to A though, this is adjacent. And then this would be my little c. The A and the B and the C may not always be in these same spots. It's up to you how you draw it if a picture is not drawn. You could also put the A up here, the B here. It really doesn't matter where you put the letters. But what will be important is that opposite angle A will be lowercase a, opposite uppercase B will be lowercase b, and so on. So I'm going to find all of my 6 trig functions, and I'm going to tell you what you need to memorize. So I'm going to do them all in relation to angle A. So if I wanted you to do the sine of angle A, what you would do is you would get the numbers from these sides, and you can either memorize it like we did in 5-1 and memorize it as y over r, or use the acronym of SO and do opposite over hypotenuse. And then for cosecant, we saw this already as CSC, and again, in relation to angle A, it would be flip that, r over y, or hypotenuse over opposite. You just flip the fraction. Then that would be using the SO part of it. And then for the next one, for the CA, that's going to be my cosine. And if I do cosine of angle A, that's going to use, if you memorize from 5-1, the x over r, or using your SOHCAHTOA, adjacent over hypotenuse. Then the secant, that is the SEC, and that's going to be r over x, or hypotenuse over adjacent. And then lastly, you could do your TOA, or your tangent. So the tangent of angle A, y over x, or using the TOA, opposite over adjacent. Cotangent, just flip that, x over y, or adjacent over opposite. Again, remember, you're only doing these 6 trig functions for the acute angles. So in my picture here, I would either ask you to find the 6 trig functions based off of angle A or angle B. Remember, when you go to write the names of the sides, if I was referencing angle B, then over here, this would be my opposite, this would be my adjacent, and always remember the hypotenuse is always opposite the right angle. Here's my triangle. It wants me to find the value of the 6 trig functions. So I'm going to go ahead and I want to find the value of the 6 trig functions, and I'm going to add variables here. So I'm going to put an A here, a B, and then I know it's kind of hard to see, but the right angle is right here at angle C. So let's find the 6 trig functions in relation to angle A. So let me go ahead and label my sides in reference to angle A up here. So the one straight across here, or opposite to angle A, this will be opposite. Over here is going to be my hypotenuse. Notice I'm missing it. I need to find it. And then the 24 would be the adjacent. So whenever you're missing a side of a right triangle, we need to do Pythagorean theorem. Now, if you remember back to your geometry days, this is actually going to be a common Pythagorean triple. But if you don't know your triples, what we have to do is use a squared plus b squared equals c squared. The hypotenuse is my c. It doesn't matter if the 24 is my a or the 7 is my a. The two legs that form the right triangle or the right angle, you can mix those a's and b's up. But I'm going to go ahead and say that the 7 is going to be my a, and then this will be my b, and then I'm looking for my hypotenuse. So let's fill it in. We're going to do 7 squared plus 24 squared equals c squared. I have to follow order of operations here. I can't add 7 and 24 first. I have to evaluate the exponent first. So 7 squared is 49. 24 squared is 576. Now I can add them, and I get 625. And now I'm going to square root it. I don't want c squared, I just want c. And technically what we're getting here is both positive and negative 25, but I don't want a negative hypotenuse length. I only keep the positive answer. The hypotenuse is always a positive number. So this will be 25. Now that I have the length of all three sides, the opposite, the adjacent, and the hypotenuse, now I can put them into the 6 trig functions. So now, let's say you're going to use the x, y, and r instead. You could also have found your r value by doing x squared plus y squared underneath the square root. The adjacent is always going to be your x, the opposite is going to be your y, and the hypotenuse is going to be your r. So if you want to do it that way, what you covered in 5.1, you can. So here, same thing. I would be doing 24 squared plus 7 squared, 576, 49, 625, square root it, and I get 25 as well. So now, let's go ahead and fill them in. So I want to find the sine of A, and remember you're going to memorize this as either y over r, or we could use our SOHCAHTOA, so this would be so, opposite over hypotenuse. So my opposite is 7, my hypotenuse is 25. Then its reciprocal is cosecant. Flip the fraction, r over y, or flip it to hypotenuse over opposite, and it's 25 over 7. Next, we'll do the cosine, and that would be the cup. So that would be cosine of A, x over r, or adjacent over hypotenuse, and this will be 24 over 25. No calculators here. All we're doing is plugging in the sides of the triangle into our fractions. And then the reciprocal to cosine is secant. Flip it. Hypotenuse over adjacent, 25 over 24. And then lastly, the TOA. So that would be tangent. And that's going to be y over x, or if you're using TOA, opposite over adjacent. And again, fill it in, 7 over 24. Cotangent, it's reciprocal. Flip it, x over y, adjacent over opposite, 24 over 7. So when they ask you to find the value of the 6 trig functions, this is all we're doing. We're just going to identify our opposite, adjacent, and hypotenuse. Or again, adjacent would be x, opposite would be y, hypotenuse would be r. So you could do it either way. Change these to a 3 and this one to a 5. So this is one that shows up on standardized tests all the time. So if you already recognize that this common triple is the 3, 4, 5, you don't have to do a squared plus b squared equals c squared. This would be your c. And again, if I put in variables here, this could be your b, and this would have been your a. So if you had to do it, you could do a squared plus 3 squared equals 5 squared. This time we subtract in order to get our a value. So when they give you the hypotenuse, you're squaring and subtracting. And then square root, and then a is the 4 that I already put in there. But again, this is a common triple that shows up on standardized tests. If you don't want to memorize it, you just do a squared plus b squared equals c squared. All right, so now that we have all 3 sides, let's go ahead and let's fill in our functions again. Now again, you could do it either based off of A or B. So let's say this time I ask you to find the 6 trig functions in relation to angle B. So let me label my sides in relation to the B. This is now opposite. This would be adjacent, and this would be hypotenuse. So again, sine, we could either use our acronym SO. So sine of angle B would be either opposite over hypotenuse or y over r. And then here we would just put in 3 over 5. Remember, this is y, this is x, this is r. The reciprocal is going to be cosecant. Flip it, O over H over O, or R over Y, 5 over 3. Then for the next one, the cosine of B. And again, I could have done A again. This will be adjacent over hypotenuse, or X over R. So my adjacent is 4, my hypotenuse is 5. Reciprocal is secant, flip it, H over A, or R over X, and then 5 over 4. Just flip the fraction. And then the last one is TOA, tangent and its reciprocal. So tangent of B, O over A, or Y over X. Opposite is 3, adjacent is 4. And then cotangent of B, flip it, X over Y, 4 over 3. Okay, so we have 2 special right triangles. The one on the left, this one is called our 45, 45, 90 special right triangle. If you remember back to geometry, remember the 3 angles of a triangle should always add up to be 180. So if we already are given that one of the angles is 45 and we have a right angle, then adding 45 plus 90 and subtracting it from 180 would also tell me that this other angle up here is also 45. Also, if you could recognize that because we have these 2 sides that are the same length, this is an isosceles triangle. And when you have 2 sides that are the same, you're also going to have the 2 base angles that are the same. So when I teach this to my geometry class, I first introduce this as the 2 legs or the 2 sides forming the right angle. I describe this as being A and A, and then the hypotenuse is whatever A is with square root 2 behind it. But what we're going to be working with is we don't need the variable part. All we're going to use are the coefficients or the numbers. So I'm going to say the 2 legs or the 2 sides forming the right angle, they're each going to be a length of 1. and then the hypotenuse is going to be the square root of 2. The second special right triangle that we have here is called the 30, 60, 90 right triangle. And what you're going to memorize is the side across from the 30 is going to have a length of 1. The side across from the 60-degree angle will have a length of the square root of 3. And then the hypotenuse, the biggest side, will be a 2. So this is the 1, 2, 3 triangle. Now you may think the 3 is bigger than 2, but the square root of 3 is actually smaller than 2. It's about 1.7. So it makes sense. The biggest side is across from the biggest angle, smallest side across from the smallest angle. Now one thing that helps me to remember which one gets the square root of 2, which one gets the square root of 3, in my 45, 45, 90, I've got 2 angles that are the same. So since I have 2 angles the same, that's the one that'll have the square root 2 in it. For the 30, 60, 90, this has 3 different angles, a 30, a 60, and a 90. So this is a clue for me that there'll be the square root of 3 in that one. So little tricks, whatever it'll take, but memorize what goes on each side of your triangles. Okay, so here it says to find the following. And again, we're doing this without a calculator. We're going to leave our answers in simplest radical form and as a simplified fraction. So what I'm going to do here is I'm going to use my special right triangles. So for the first box, example 3 here, I'm going to draw my special right triangle here. And then I'm going to put in my 30 and my 60-degree angles. I'm going to label my sides in relation to where they are. So across from the 30, you're memorizing this as being 1. And then across from the 60 is the square root of 3. And then across from the 90-degree angle, this is going to be your 2. Now, like I had just said to Eva, the side that is horizontal, this is going to be your x value. The side that is opposite the 30 over here going up and down, this will be your y, and the hypotenuse is going to be your r. So let me go ahead and label my sides in relation, because all of these questions want the 30-degree angle. So let me go ahead and label my sides based off the 30. So over here, this is going to be my opposite. This is going to be my adjacent side. And this is going to be my hypotenuse. So for sine and its reciprocal, here I'm going to be doing the so. So I'm going to do opposite over hypotenuse. So 1 over 2. And then reciprocal, flip it, 2 over 1, and cosecant is 2. For cosine, we're going to do the ca. So we're going to do adjacent, so square root 3 over hypotenuse, which is 2. For secant, we flip that fraction, 2 over square root 3. We must rationalize. We cannot leave the radical in the bottom. So I'm going to multiply the top and the bottom by square root 3. So 2 square root 3 over 3. Now, if you're doing this on your calculator and you hit the cosine of 30, your calculator will not give it to you as the square root of 3 over 2. It's going to give you a decimal. Okay? On the test, you will have a calculator portion and a non-calculator portion. And I will want these types of questions. This will come from the non-calculator. You'll have to draw the triangle and give me the answer in simplest radical form. So let's try the tangent now. Tangent is the TOA. So if I do opposite over adjacent, notice again I've got a radical in the denominator, so I have to rationalize. Multiply top and bottom by square root 3. So the final answer here is the square root of 3 over 3. Cotangent. Now, my advice to you is when you go to write the reciprocal, don't flip the rationalize answer. Flip this one, the first one. Then you don't have to rationalize. So if you just flip it and put it in as root 3 over 1, then it just simplifies to the square root of 3. If you flip the rationalize one, then you're going to have to go back and rationalize again. Okay, so I'm going to redraw the triangle. I'm going to put in my 30, 60, 90. And again, it doesn't matter if you put the 30 up at the top. What's important is that the side across from the 30 is 1. The side across from the 60 is the square root 3. And then the side across from the 90 is 2. Now what I need to do is label my sides in relation to the 60. So now the square root of 3 is now opposite. 2 is the hypotenuse still. And then this is my adjacent in relation to the 60. So now let's fill it in. So again, for sine, we're doing so. So for this one, we're going to do opposite over hypotenuse. And then for the reciprocal, we flip it. Cosecant, rationalize 2 square root 3 over 3. For cosine, this is going to be our adjacent over hypotenuse. So that'll be 1 over 2. Secant, the reciprocal, flip it. 2 over 1, which is just 2. And lastly, TOA, which is tangent, opposite over adjacent, square root 3 over 1, which simplifies to square root 3. For the cotangent, flip it. 1 over the square root of 3. I got to rationalize. And I get square root 3 over 3. Now, probably back in your geometry days, they probably taught you that the sine of one of the acute angles is going to give you the same measure as the cosine of its complement. And if you remember, complementary angles are 2 angles that add up to be 90. So if you notice here, the sine of 30 is the same thing as the cosine of 60, because 30 and 60 are complementary angles. And then same thing here, cosine of 30 is the same thing as the sine of its complement. So these are going to give you the same answers. And this is for sine and cosine. Okay, so I'm going to draw the triangle. So I have 45, 45, and 90. This is a 1, and a square root of 2. Now, if you notice, when I go to label my sides as opposite and adjacent, notice it really doesn't matter which 45 I pick, because opposite and adjacent are both going to be 1, no matter which 45 you look at. So if I label them in relation to the 45 I just colored, this would be opposite to that 45, this would be adjacent, and this again is the hypotenuse. So let's fill it in. So again, for sine, we're going to do our opposite over hypotenuse. So 1 over the square root of 2. I got to rationalize. Square root 2 over 2 is the sine of 45. Now again, when I go to do the reciprocal, don't take the rationalized answer. Go back to this one and then just flip it. And then it goes to just the square root of 2. Cosine, it's going to be the same thing. This will be our adjacent, which is still 1, over square root of 2. Rationalize again. Square root 2 over 2. Secant, flip it. Square root 2 over 1, which is just square root 2. And then lastly, the tangent, which is the TOA, Opposite over adjacent, 1 over 1, and it equals 1. Reciprocal, flip it, 1 over 1, it's still a 1. Now, when we get to the calculator portion of this test, I'm going to have you clear your calculators just like we do always. However, when you do that second plus 712, the default setting is in radians. So after you clear your calculator, I'm going to tell everybody hit the mode button and change your calculator from radians to degrees. So you're going to have to change it after you clear it, because if you don't do that and you don't pay attention, you will fail your test because you will have calculated everything in radians, which gives you a totally different answer. So when you take this test, I'm going to tell everybody, clear your calculator, show me RAM cleared, but then hit the mode button and put it back into degrees. Now, one way to confirm that you did hit that and select degrees is hit the tangent button, hit 45, hit enter. You should be getting the answer of 1. If you're getting a crazy decimal, you're still in radians. So that's what I'm going to announce to everyone when we take this test, is to clear your calculator, put it back in degrees, and then check it by doing the tangent of 45. Memorize that the tangent of 45 is 1. It'll make your life a lot easier when confirming if your calculator is in the correct mode. Some of the scientific calculators in the display, it puts the letters DEG, and you know you're in degrees. I don't believe it shows you that in the graphing calculator. You would have to hit the mode button and see what word is highlighted. So what we're going to be talking about on this slide are reference angles. Now, what I like to do is whenever I refer to a reference angle, I'm going to abbreviate that as RA. So your reference angle is always going to be an angle that is going to come from quadrant 1. And our reference angles that we're going to be calculating without our calculator are going to come from the special right triangles. It's either going to be a 30-degree angle, a 60-degree angle, or a 45-degree angle. These are going to be the reference angles we'll talk about when we're not using our calculator. And what we're going to be doing on our coordinate plane is creating our special right triangles. And when we create our special right triangles, we're always going to draw that leg of the right triangle back to the x-axis, never to the y-axis. So once we create our triangles, they're going to sort of look like a bow tie. So for example, let's say I graphed a 30-degree angle. Then I would make my triangle go back to the x-axis, and that would be the triangle I create. So that would be my 30 degrees. Let's say I wanted to graph a 135-degree angle. I don't make it go back to the y-axis. I would continue it and make it go down to the x, and then here's my 45-degree angle. Let's say I wanted to graph a 210-degree angle. I'd use my terminal side. Again, I would go back to the x-axis. So my 210, I would go 90, 180, and then 30 more. And that would be my reference angle for the 210. This could have been a 135 up here. And then this was the 30. Now let's say I want to end up in quadrant number 4. And let's say I ask you to graph a 330-degree angle. So I would again swirl around, come around here, make my terminal side. Notice here I went 90, 180, 270, and then another 60 degrees to get to 330. So when I make my triangle, it's back to the x-axis, and this one would have a reference angle of 30. It's never back to the y-axis. So it sort of looks like I'm making a bow tie here. But you're going to do them not more than one angle in your coordinate plane. You'll do one angle in each X and Y axis. So this is where your triangles should look like. It should be sort of looking like you're making a bow tie. So now, over here, at the bottom in these little words here, this is how you could calculate the reference angle. So in quadrant 1, if I ask you to graph a 60-degree angle or a 45, obviously it's going to end up in quadrant 1. But if I wanted you to graph something in quadrant 2, so for example, the 135 that I graphed, you'll take 180 minus 135, and that would give you your reference angle. And then that's going to be the sides of the triangle you're going to form. Then in quadrant 3, I had asked you to graph that 210. Here you take the angle and you subtract 180. And then that would give you your reference angle. And then in the last quadrant, you take 360 and subtract the angle that they're asking you to find the answer for. And again, that gives you your reference angle. And that would be the sides that you're going to label, the opposite, adjacent, hypotenuse, in relation to that 30-degree angle. So it wants me to find the sine of 210 degrees. So I'm going to go ahead and I could either do it by finding my reference angle, or I'm also going to graph it. Now, one other thing to keep in mind is that we have our order pairs. So this is quadrant 1. And remember, the order pairs in quadrant 1 are positive, positive. Also in quadrant 1, all 6 functions are positive. In quadrant number 2, the order pairs are negative, positive. And this is where we saw the word students, which represents sine and cosecant. These are the only positive functions. And then in quadrant 3, this is where we had a negative, negative order pair. This is where we had take, and the T stood for tangent and cotangent. Those are the only positive ones. And then quadrant 4, the signs on the order pair are positive, negative. This is where we saw calculus, and the C stood for cosine and secant, being the only positive functions. So you're going to graph the angle, whichever quadrant it ends up in. That's a way that you can confirm the signs. We are going to create a triangle. So let's go ahead and graph the 210-degree angle. And this is all without a calculator. So you're going to come around. I'm going to start here on my initial side. And then I'm going to swirl around to 90, 180. And then I have to go 30 more degrees. And that would be my 210-degree angle. So this is 210. Now I make my triangle. It goes back to the x-axis. So this additional amount that I went after the 180 was 30 degrees. My right angle is going to be here. And then my 30 degrees is up there. That's my theta, or my angle I'm referencing. That's my reference angle. And now I'm going to label my sides. So the side across from 30 is 1. The side across from 60 is the square root of 3. And then the hypotenuse, or this terminal side of the angle, is a 2. Now remember, in quadrant 3, the signs on my order pair are negative, negative. So this would be a -1 and a negative square root 3. That hypotenuse, that 2, will always be positive. So now, you can either choose to put the signs on the x and the y values, or just know when you're done, sine in quadrant 3 is going to be a negative answer. So now, what I can do here, just like this is my x-axis, this square root of 3, this is my x value, this is my y value. Now, if you want to go ahead and do it as opposite and adjacent, and this is hypotenuse, you can also do it that way. So to find sine of 210, I can either do opposite over hypotenuse, because this is the so, and then this would be y over r. So my side that's opposite is -1, and my hypotenuse is 2. So the answer of sine of 210 is -1/2. The previous slide, it told you to find the value of your reference angle in quadrant 3, to take the angle measure, and then subtract 180, and this gives you the reference angle, the RA. So if I did 210 minus 180, I get my 30 degrees. So as long as you understand where this angle is ending up, you can also do that calculation to get the reference angle, and then just draw your triangle. Not necessarily in the coordinate plane. Let's try the next one. 300-degree angle. So let's go ahead and graph it. So I'm going to start here on my initial side. I'm going to go around 90, 180, 270, and then 30 degrees more. So when I make it go back to the x-axis, to complete it, the shortest way to get to the x-axis to complete my circle there would be another 60 degrees. So then now, what I need to do is go ahead and figure out what my sides are. So here's my 30, here's my right angle. So across from the 60 is the square root of 3. Across from the 30, okay, this is 1, this is 2. The signs here are positive, negative. So this would be a positive, this would be a negative. Tangent, so this is going to be opposite, adjacent, and this is hypotenuse. This is your R, this is your Y, this is your X. So either opposite over adjacent or Y over X, and it'll be negative root 3 over 1, which equals negative square root 3. And that would be the tangent of 300. 30 more degrees here to get to this terminal side, but we always want to make our triangle back to the x-axis. So I had to figure out what this angle was to finish to get to the x-axis, which was another 60 degrees. Now again, remember, you can recognize that the x-axis is here. So this is where your x value is. Y-axis is up and down, so this is where your y value is. Or again, just label them as opposite, adjacent, and hypotenuse. And the angle, the reference angle, is always going to be located right here. So another way to find the reference angle is if you know it's in quadrant 3, the 300-degree angle, you can also do 360 minus the angle, and then you can see your reference angle is going to be 60 degrees. So let's go ahead and try do number 8. So this one, we're going to have to swirl around more than one time. So if I take my 675 and I subtract 360, I'm going to end up with 315. So this tells me I'm going to start here on my initial side. I'm going to go around one full circle for 360. And then I have to go another 315 degrees. So 90, 180, 270, and then another 45 degrees to create the 675 degree angle. So now again, we always create our triangle back to the x-axis. So your right angle is here. So remember, we went 45 degrees to get to this terminal side. So then my reference angle is right here. It's 45 to continue on to get back to the x-axis. So this is my 45, 45, 90 right triangle. The two legs are 1 and 1. Your hypotenuse is going to be the square root of 2. And again, we're going to label our sides in relation to the 45-degree reference angle here. So this is the side that is opposite. It's also the y value. This will be the adjacent or your x. And then the square root of 2 is your hypotenuse or your r value. So they want us to do tangent. So tangent of 675 is going to be opposite, if we're doing the TOA, opposite over adjacent. So this is going to be 1 over 1. Now also, remember the signs on your ordered pair in quadrant 1 are positive, negative. So the x is going to be positive, the y is negative. So tangent is y over x. So negative 1 over positive 1 simplifies to negative 1. Also remember, if you just do your all students take calculus, remember the only positive ones here are cosine and secant. So tangent should be negative when you graph an angle that ends up in quadrant 4. So let's go ahead and try the last one. It's a negative angle. So let me go ahead and graph a negative 240. So when I go to graph this angle, I'm going to go negative 90, negative 180, and then I need to go 60 degrees more, and this will create my negative 240 degree angle. Now remember, this 60 degrees, this is my reference angle because I'm making my triangle back to the x-axis. So then 30 is up here, and I'm going to label my sides based off of the 30, 60, 90. So this is going to be 1, this will be root 3, and this will be 2. Another thing to take into consideration is the signs in quadrant 2. We know the signs on the ordered pair are negative, positive. So my x value here is negative, my y will be positive, and the r is always going to be positive. So this is r, or the hypotenuse. This will be opposite, or your y value. And this will be adjacent, or your x value. We're doing cosine of negative 240. Remember, cosine is going to be x over r, or adjacent over hypotenuse. So once we put in these numbers, we can see that the adjacent is negative 1, my hypotenuse is 2. And again, remember what we're doing here is we're in quadrant 2. So again, if you do your all students take calculus, the only ones that are positive here are sine and cosecant. So cosine should be a negative fraction. If it's not, or a negative answer. If it's not, you've done something wrong.